Hello everyone. So today we are going to discuss about the one of the popular neural network is called as back propagation neural network. It is a multi-layer feed-forward neural network consisting of an input layer, hidden layer, and output layer. So the neuron between the input layer and hidden layer. So between the input layer to hidden layer, we are having the connection link. So the connection link we have to represent by V in terms of V. Okay, the weight between the input neuron 1 to hidden neuron 1, that is we have to represent by V11. Similarly, the weight between the input neuron 2 to hidden neuron 2 we have to represent by V22, and similarly for up to nth neuron we will be considered N1, that is for the nth neuron of the first that is input layer and the hidden layer we have to represent by VNN. Okay, so see this is the architecture of the back propagation neural network. The x1, x2, xi up to xn, this is the input neuron, or it is called as input layer, and z1, zj up to zp, this is acting as a hidden layer or hidden neuron, and the y1, y2, yk up to ym, this is nothing but the output neuron. So here the weights between the input neuron to hidden neuron we have to represent in terms of V, and the weights between the hidden neuron to output neuron we have to represent in terms of W. So the way after this the net result is fed back to the input side to update the weights. So, you have to consider some parameters in the back propagation neural network. X is nothing but the input training vector, T is nothing but target output vector, alpha is nothing but the learning rate parameter, Xi is nothing but input unit, Voj is the bias of the hidden unit, W is nothing but bias of the kth output unit. So, here the hidden unit Zj, the neuron of the Zj, the net input value I have to calculate by using that formula Zin j equal to Voj is nothing but bias plus the summation of Xi into Vij. From that you have to calculate the net input value. Then from this you have to calculate the output. Output equal to Zj is equal to the function of Zinj. Okay. Similarly for the Yk, the output unit k, the net input value Ynk equal to bias. Here the bias value is we have to represent by W. So W plus summation of j equal to 1 to p Zj into Wjk. So by using this formula, I have to calculate the net input value of Yk neuron. And the output, I have to calculate Yk equal to function of Ynk. Okay. So now we have to calculate so that is for an output value, output neuron values. Then the values we have to check with the target value. If the error is there, I have to update the error. So the error between the output layer and hidden layer we have to consider the del k, and the error between the hidden layer and the input layer we have to consider nothing but del j. Okay. So based on that our required output, so we have to change we have to update the weights based on the target value. So this is the training algorithm of the back propagation neural network. The first step, initialize the weights and the learning rate, and step 1 preform step 2 to 9 when stopping condition is false. Step 2 is nothing but perform step 3 to 8 for each training pair. For the feed forward phase 1 will be considered. Okay, for the phase 1, each input unit receives input signals and sent to the hidden unit, and then each hidden unit sums its weighted input signals to calculate the net input. Okay, so you have to calculate the Zinj. From that you have to calculate the output values Zj. So then I have to calculate the output unit for the hidden layer to output layer. Okay, that is for Ynk equal to bias plus summation of j equal to 1 to p Zj into Wjk. Also already we discussed, isn't it? You have to use that same formula, and then we have to calculate the So net out input values, from that we have to calculate the output value. Okay. So now the neural network and the output neuron have the output. So the output is checked with the target value. Okay. If if there is any deviation, so then I have to update the weights. Okay, between the output neuron to hidden neuron and hidden neuron to input neuron by using this formula. Okay. So in the output neuron to hidden neuron, we have to consider the error values, that is for del k, that is equal to tk minus yk in first derivative of yin. By using that formula, I have to update the weights between the output neuron to hidden neuron. Similarly, for the hidden neuron to input neuron, I have to update the weights by using that formula del j equal to del inj, first derivative of z inj. Okay. So after calculate the change in weight value, I have to update the weights between the new old value to new value. So what is the new values? So new weights wik, new equal to wik old plus change in weights. Similarly, the new weights between the hidden neuron to input neuron, that is nothing but vij new equal to vij old plus change in weights. Okay. So I have to repeat this step up till I have to target values is equal to output value. Okay, if once the target value is equal to output value, so then we have to stop the conditions. Okay, so this is the training algorithm of the back propagation neural network. So this is one of the popular neural network. It will be used for many applications. Okay, thank you.